Good morning, Algebra 1. This is 5.2, Algebra 1, Apex Semester 2. Today we are going to talk about graphing quantitative data. So in other words, we're going to talk about graphing numbers and different ways that we can graph them and different ways that we can use those graphs. So the first one that we are going to talk about today is a modified box plot. This is also called a box and whisker plot. So the first thing that we're going to do is we're going to create a labeled number line that goes from the lowest value to the highest value. And you might have to, skip some numbers, which you'll see we'll do here. We're going to put, so we're going to label this, and this is the same data we've been using. So I'm going to start at 0, and it has to go all the way up to 150, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, and 150. And then it says to put a dot above each outlier. And we already found that 150 was our outlier in lesson 5.1. So if you haven't watched that, you have to watch that so that you know what to do on these. So we're going to put a dot above that outlier. That's our only outlier. Outlier. And then we're going to put a dot, will go above the lowest value that is not an outlier. So that value would be 0. And then we're going to connect this to the left side of the box. The left side should be drawn at the first quartile. And we found all of this out, in lesson 5.1 again. So if you didn't do that, you need to go back and do that. So our first quartile will be right here at 10. The right side of the box should be drawn at the third quartile. And then we're going to draw a line in the middle of the box at the median. Okay, not middle, at the median of the box. Okay. So our third quartile value was 60. Okay, so here's our box. And our median was 45. And now we're going to connect these lines here. Okay, we're going to put a dot above the highest value that's not an outlier. So that value is 90. And we connect those. We don't connect the outlier to anything. Okay? So above the highest value that is not an outlier. Okay? So that is our box plot, or our box and whisker plot. Okay, we can also sometimes plot 2 of these or more on the same chart. And when we do that, the result is a comparative box plot. In other words, we're comparing a couple of different box plots to look at different data. Okay. So box plots, not too scary, I hope. Okay. But you have to be able to find the mean, median, mode, range, first quartile. You have to be able to find all that to do those. Okay, so the next one we're going to look at is a frequency table. So a frequency table shows each data element and the number of times it occurs. So we're going to complete this frequency table for the following values. So all we're going to do, we're looking for numbers that include and between 0 and 19. Okay, so I'm just going to look here. Oh, there's 1, 2, 3, 4, 5, and it looks like 5 of them. Okay. All right, so now we're going to find all of the numbers that include 20 and 39 and are between them. Okay, so 1, 2, 2. Yep. Okay, so now 40 to 59. So there's 1, 2, 3, 4. 60 to 79. 1, 2, 3, 4, and 80 to 99. 1, 2, 3, 4, 5. All right, so that's a frequency table. It just tells you how many times numbers occur. Okay. So our next one is going to be a stem and leaf plot. Okay, so a stem and leaf plot, data values should be listed in order. Okay, so that's the very first thing. And if you look down here at our example, they are listed in order, so that's good. Okay. Next, it must be determined what the stem will represent and what the leaves will represent. So we're going to want to do a key with this. Okay, so when we make this, so looking at this one down here, I would say that my key is going to be 2, and my leaves, so this is my stem, and these are my leaves. Okay, so it would equal 0.26 seconds. Typically, the leaf contains the last digit of the number, and the stem contains all other digits. So the leaf contains the last digit of the number, and the stem contains all other digits. Okay. So that's what we did here, okay? Just that last digit. In the case of very large numbers, the data values may be rounded to a particular place value that will be used for the leaf. Okay. So if they're really big, we can round them to use for the leaf. Okay, so that way we don't have 8 places. The remaining digits to the left of the rounded place value are used as the stem. So, if I had 3.4762, right, I would round that to 3.48. Okay, this would be my stem, and this would be my leaf. Okay, so 3.4 would be my stem. Never skip a stem, even if there are no leaf or are no leaves for that stem. And we're always going to include a key and a unit label. Okay, so here, there's our key, and our unit label is seconds. So it's 0.26 seconds. Okay. So the first thing I'm going to do, I'm going to create a stem and leaf plot. Okay, so I've already got this. Okay. So I'm just looking, so remember, this is just this first number. Okay, so my stems are going to be my first values right here. So I'm going to have a 2, I'm going to have a 3, I'm going to have a 4, I'm going to have a 5. And even if I didn't have a 4, or a 3, I would still include that on my stem. Okay, there just wouldn't be any leaves for it. Okay, so now I'm going to do my leaves. So my leaves are my last number. So for 2, I have a 6 and an 8. For 3, I have a 1, 2, 4, and 5. And for my leaves here, I have a 4 and a 7. And for my 5, I have a 9. So now I can look at a couple of things. I can calculate the measures of center for the data. Okay, so my mode, okay, none of these data repeat, so there is none. Okay, remember, the mode is the one that occurs the most often. Our median is the one in the middle, so we can look at this and we can count in, or we could look at this. So it looks like to me it's going to be 0.34. Okay, so that's my median. Okay. My mean, I need to add all of these up. Okay. So if I add all of these up, I get 3.33. Okay. And there's 9 of them, so I'm going to divide by 9. Okay. So I get 0.37 is my mean, or my average. The measures of spread, okay, these are going to be my first quartile, my third quartile, which I'm going to need to know in order to calculate my IQR, okay, my interquartile range. Okay, and then I'm just going to do my range. So my first quartile, okay, the middle of the first quarter is those two added together, so 0.28 plus 0.31 divided by 2, and that gives me 0.295. My third quartile are these two added together. So 0.44 plus 0.47 divided by 2, and that gives me 0.455. So my interquartile range is at 0.455 minus 0.295. Okay, so subtracting 0.455 minus 0.295 gives us an interquartile range of 0.16. And our range is just our largest number minus our smallest value, okay, which gives us 0.33. So next we need to determine if there's outliers. So for our first quarter, we'll take that 0.295 that we found, okay, and we're going to subtract that 1.5 times our interquartile range, which is 0.16, and we would get 0.055. So are there any numbers less than that? No. Okay, so now we need to check our third quartile. So that's going to be 0.455, and that's going to be plus, because we're looking to see if there's anything bigger, 1.5 times 0.16, which is going to be 0.695. There's nothing bigger than that, so there are no outliers. All right, so I have a different page here because this graph printed wrong, so hopefully you guys all got the corrected version. So the first thing we're going to do here is we are going to talk about a histogram, which you guys have seen these for years. You've seen them, you know, in elementary school and middle school, but we're going to talk about actually how to write one, and then finding our mean, median, mode. So a histogram looks like a bar graph, but it has no spaces in between them. The bin width refers to how wide we want our intervals. So just like with a bar graph, we're going to have intervals where we're going to have, you know, shade, however many fit that. So the next thing we're going to do is we're going to determine our starting value on the x-axis. It could be the lowest number or a number below that. For example, you know, if we had a 33, we might just want to start at 30. And the numbers on the x-axis will be the starting value increasing by the bin width. So let's go on ahead and take a look. It says determine the amount of data in each interval. And remember that each number on the x-axis is included in the bar after the number. Okay, so that's one thing to remember when we're setting this up. The y-axis will list the frequency starting at 0 and increasing by 1, okay, which is the amount of numbers in each interval. So a good histogram will have between 5 and 15 classes or intervals. Okay. It will have no overlap, okay, between the classes or the intervals, and it will have equal class size. In other words, you know, I won't want one of these to go for 5 and one of these to go for 10. Okay, so if I choose a bin width of 5, I'm going to stick with a bin width of 5. Okay. All right, so let's go on ahead and look at these. So looking at these, you know, if I were to go in point, you know, in tenths, I would have 4 in that one. I would have, looks like quite a few in that one. And then I would have a few in that one, 1 in that one, 3, 1 and 1. Okay, but I also know that I need to have enough room here. So I'm going to go on ahead and start at 0.2. And just include everything that's within that tenth of a decimal. So 0.5, 0.6, 0.7, 0.8, and 0.9. Okay. And then my numbers are going to go up, and in this case, they're increasing by 1. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So now I have 1, 2, 3, 4 numbers that start with a 2. So here, I'm going to color in 4 numbers. Remember, I'm always looking at the box after, so 0.3 is included in this one. So 0.3, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I didn't have enough room to do 10 here, then I would have to rethink the way my bar was set up, right? My x-axis. Okay? I might have to combine, go from 0.2 to 0.32, okay, or 0.33. That's why it's good for you to look at them and count them in advance. So here, my 0.4s, I have 4 of them. 0.5, I have 1. 0.6, I have 3. 0.7, I have 1. And 0.8, I have 1. Okay. So there's my histogram. Okay. So not too bad to make. It's like a bar graph, but there's no spaces in between. Okay. All right. So now we're going to calculate the measures of center, okay, just like we have. So our mode, okay, well, just looking at this histogram, we can see that our mode is going to be somewhere in the 0.3 range. And if we look at our 0.3 range, we have 1, 2, 3, 4 of them that are 0.34s. We have 3 that are 0.35. So it's going to be 0.34. Our median, we're going to have to find the middle here. Okay, so if we start here, well, this one's kind of easy because these are in charts. So it's going to be the average of those two values. Well, they're the same, so it's 0.35. Okay. Our mean, we're going to add all of those up and we get 10.2. And we're going to divide by how many there are, and there are 24 of them. There were 24 sophomores, so there better be 24. And we're going to get 0.425. So now we're going to calculate the measures of spread. So we're going to do our first quartile, our third quartile again. We're going to do our interquartile range, and we're going to do our range. So our range, we can do it anytime. So that's just 0.82 minus 0.25, okay, and that's going to give us 0.57. Our first quartile, okay, so the middle is here. Okay, so I'm going to go to the middle of the middle, okay, and that's going to be 0.33 and 0.34. So I'm going to add those together. And I'm going to divide by 2, and I get 0.335. In my third quartile, same thing. So it's going to be between 0.47 and 0.5. Okay, so 0.47 plus 0.5 divided by 2 is 0.485. Interquartile range, I'm going to subtract these two, 0.485 minus 0.335, okay, and that is going to give us 0.15. Okay, so now I need to determine my outliers. So I'm going to do my first quartile, okay, and that's going to be 0.335 minus, and it's always 1.5 times our IQR. Okay. And that's going to be 0.11. So there's nothing below that. Okay, so the lowest we go is 0.25. So now let's check our third quartile. So that's going to be 0.485 plus 1.5 times that IQR. And that equals 0.71. Okay, well, we have a 0.7 here, so that's not outside of it, but this 0.82 is an outlier. Okay. Okay, so let's go on ahead. So like I said, mine kind of printed weird, so that's why I did it on a different sheet of paper. All right, so let's go on ahead and look at a dot plot. Okay. So a dot plot is where we are going to use a labeled number line. And we're going to determine the interval of the numbers just based on how many numbers there are and how long we want our number line to be, sorry. We're going to label the units for the number line. Or in other words, we're going to put our values here. Okay, and then we're going to place a dot above each value in the data set, or where the dot should approximately go. And then each dot should be approximately the same size. Now we're going to graph this thing. So it says a random sample of 25 seniors was chosen and their travel time to school is listed. Create a dot plot for the data. So the lowest travel time was 5, the highest was 45. So we're going to need to fit all of those on our line. So it's not going to be ideal to go by ones. 10s, you would probably get spread out, right? So we would be done about halfway. So let's go by 5. So that's going to be 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So now we're going to go ahead and we're going to put dots. So, and you've seen some of these that are kind of like a dot plot, but they have little X's above them, like a frequency plot. Okay, but this one is a dot plot, so we're going to use dots. So 5, there's going to be 3 that are 5, a 1 that's a 6, 2 that are 7s, 1 that's an 8, 4 that are 10s. So I'm just counting how many times does it show up in our chart. Okay, 2 that are 12s, 2 15s, 1 16, 1, 2, 3, 4 20s, 22, 25, 25, 25. Oh, I put my 22 in the wrong spot. There we go. So now there's 3 25s, and then there's a 45. So, I mean, just looking at this, right, we can figure out our measures of center and our ranges, but our measures of spread, which are our ranges and our IQR and stuff, and our outliers. But just looking at this, I would think, I'm not 100% sure because I haven't figured it out, but I would think that 45 would be an outlier, right? So that might be someone that lives out of the district or something, and so it just takes them a little bit longer to get to school. These can tell you a lot, and in the next section, we're going to talk about some things that these plots can tell you, some things that the graphs or the graphs of this quantitative data can show you. So have a great day, and I'll see you next time.